doing? Welcome to live stream number 81. It is Friday. We made it. Made it to Friday. It is October 20th, 2017. Thank you so much for taking the time to join today's live stream, where we are going to chat about where to pick up your part, and we're going to straighten out all confusion about G54, G55, work offsets, probing, and all that stuff inside of Fusion 360. It is all about CAM today. I hope that I've been looking forward to this. I hope you have. If you're watching the recording, thank you so much for taking the time to watch that. If you are, we have a few people already joining the live stream. If you're checking in there, absolutely appreciate you taking time on your busy day to watch that. Okay, we should have a bunch of great people joining us today. One, I just got to give a shout out quickly for the people who are in the live stream. Al Watmow, my good friend Al, who is product manager for Fusion 360 CAM, is going to at least plan on trying to attend the chat. So if you have any questions about CAM at all, he's the guy to talk to. If you're watching the recording, just put it down in the description area, and I will make sure that I'll get back to you as soon as I can, as fast as I can. So that was Al's introduction. Thank you so much. Let's jump into Fusion 360 and talk about picking up your part, work offsets, probing, how all this works. This comes out of last week's live stream. We had some good live stream this week, but last Friday we talked about like soft jaws and how to do all that. And a couple of questions I got after that was, how do you really pick up your parts on the mill, even if you're doing it manually, doing it on your CNC? You know, some people have these fancy probes, some people don't. So that's what we're gonna try to straighten out today. So I have this model here of 3 models, I guess. Let me just hide a couple of them. Let's narrow this down to like just the first case here. So what I really want to talk about today is I want to talk about how Fusion 360, or also Inventor HSM or HSM Works, is handling this whole thing with your pickup. And I want to do this even like if you're brand new to milling, hopefully you can get a ton out of this today. Even if you're seasoned, maybe there's a couple of tips and tricks in there that will help you. All right, guys. I can see that we also got my good friend Bryce in here. So now it's with Al and Bryce in here, then any Fusion question is just good in the live stream. Okay, so if you look at this part, I have it sitting in a vise. And last Friday, I was making a comment about you don't always have to put things in a vise. You can get these vices. They are all available to you. If you go all the way out to kind of like your root folder or whatever that is, there is a folder down here called CAM Samples, and if you all should have access to that. You all do have access to that. And in there's a folder called Work Holding, and in here, Al and team have placed all kinds of different cool stuff. So these vices, that's where I got this vice from. These are all available to you. Now you will see here that if I go to the left view and I zoom in, you will see that I left some space when I placed this one in the vise, because we normally, when we program in CAM, we're programming to the finished part, right? But in real life, there's normally some stock around your part. So that's one of the things we're going to talk a little bit about today is like, how would I pick this up? And a lot of the stuff I'm going to do today is my preferences. So, you know, don't think that that's a rule at all. Let's go into CAM. That's where we want to be anyway. So I'm going to go into CAM here. And when I go in to create a setup, click the setup button. By the way, you can see how Fusion is selecting like a big box because it sees that this is an assembly. And right out of the gate, it says, hey, you want to machine everything? And no. So go over here to model, click on where it says nothing. And so it gets highlighted blue. Select on your part, and now that is all it will machine. So when you go in now, if we go back into the left view here and we zoom in, you maybe can see, I don't know how good it's going to show up on your screen, there is a little bit of a shadow around our part here. And the reason for that is the second tab, where we can define the stock. Because, like I said, we normally machine to the finished part, but normally when you get a piece of steel, there's some extra, you order a little bit oversized. So the second tab is where you can control all this. Now, it defaults to relative size box, what really just means that the software throws a box around it, a 3D box around the part, and then it adds a few variables. So I'm still in my metric scale here. So you will see that it added a millimeter to the side. So if I turn that to 0, and if I turn the stock top offset to 0, that means that the block is now exactly the same size as my stock. So this gives you an opportunity to add a little bit of extra stock. Now, I prefer to use relative size box if I don't know what kind of material size I'm really gonna be using. By the way, notice that the minimum sizes, if I turn this back to 0, the minimum size of the part shows up here. This is awesome. If you got to order stock and you have like some crazy model, this will show you a boundary box what that minimum size is, so you can use that to order. Relative size box is great if you don't know what size stock you're gonna get, but if you have the stock right next to you, I think you should use fixed size box, because here you actually get to put in the width, the depth, and the height of the stock. So in this case here, you will see if I go back into the left that there's no material, but if I go over here, I added 2 millimeters per side. So if I do 134, you will now see that I do get that stock showing up there. So, this should be whatever your stock is measuring is what you should see when you're in here. So that's why you see these shadows. Now, the other thing we need to talk about while we're in here is where are you going to pick up the part? So, right, as default, it says stock box point. And when you click on that, you kind of like get these, I call them white golf balls around. And if we zoom in, notice how with stock box point, it shows up on the edge of the stock. So again, if you don't define your stock correctly, but you're using the stock box, that could be an issue when you pick the part up out at the machine. Now, I'm just going to spend 3 minutes talking about what I mean when I say picking up the part out of the machine, because there might be some people here who's like, what do you mean when you say picking the part up at the machine? So, think about it like this. You have your machine out the CNC machine out on the floor, and it has a certain amount of travel that it can travel around. Well, it needs to know where you're going to place that part out in space. It doesn't know where you're putting it on the table. So the machine itself have kind of like a coordinate, or have some scales that it travels up and down, X, Y, Z. It knows its outer limits of those. So it knows how far it can go out before it would like over travel, what it will never do, but alarm out saying, hey, I can't go further to the left, I can't go further to the right, or I can't go up or down. Now, what we do in the CAM software, what we do in the machine is when we place our part in the vise, out of the machine, we go over and we tell the machine where this specific corner is on your part, so it knows where that is compared to its 0, 0. So there's a specified 0, 0 on the machine, and now you're telling, well, my part is here to that 0, 0. If you didn't tell it where the part was, it would have no idea if it's here, 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 or here, right? So when you tell it where that is out of the machine, then it knows that all the X, Y, and Z coordinates. By the way, we're gonna take a look at code today. So you're gonna get into NC code today. For anybody who gets excited about that. So that's where the code's gonna come from. Now we call that work offset. That is kind of like the terminology that is used in industry. Work offset is where we are telling the machine our 0, 0 point is for that program. So when you're looking at the screen here, that is where I'm talking about. When I'm talking about we have an intersection here, our finished part is the green one. Well, this is our defined stock. Is this where we're going to pick up the part and tell the machine that we are standing right here on this corner? Now in Fusion, this is extremely easy to control. We're doing that with this 3D triad right here. So where if I have this box point selected over here, wherever I click on one of these white golf balls, you will see that that triad jump right to where that golf ball is, right on that corner. So if I place it right here, I will tell it that this is where I am going to pick up this part. This is going to be my 0, 0. This is going to be the work coordinate system, okay? Now, how do you tell the machine that that is your 0, 0? Well, you normally, there's a couple of different ways you can do it. One way is if you have a really fancy machine, you have a probe. We're going to talk about that in the end, how that is controlled inside of Fusion, which is a really cool thing. Most of us, you dial some, you drag the handles, turn the handles, and the spindle will come over and will be somewhere around your part. Now, there's a couple of tools you can use for this. One is called an edge finder. Looks like this. You can buy this. I don't think they're terribly expensive. And there's a little spring in there, and you start the spindle, so this thing spins around. And as you're going towards your part, at some point it will go stop. So it's right now it's kind of like offset. I hope you can see that. You should see it. It's offset. But when you get close to your parts, it will go straight. Like when you're getting closer, you're just slowly dialing in. And when you see this one, it goes straight, and then suddenly it kicks out. That means that you're right at that point. And then you just divide the diameter of this in two, and that will tell you that your spindle is right over that point in that axis. And you would do that in the x-axis, and you will do it in the y-axis, so the front or the back if we are looking at this part here. Now, where you should pick up your part is somewhat a preference. There is not a rule. I normally, if I'm picking up a corner like here, I normally pick up this back corner because my solid jaw is back here on the vise. On the movable jaw, there's a little bit of play in it. So you should get a little bit of more consistency picking up on the back edge. Though, I have a good friend of mine who always picks up this corner over here. And his reason for that is that now all his code, when he posts it out, will be plus. So if he ever looks through his NC code and he sees that it's minus, he knows that he did something wrong. Well, it's not a bad way to kind of check that. Another option is to select the center of the part. And that is probably what I have done more than the corner. And I think that kind of depends on where you're coming from. So I'm a mold maker of trade, and in mold making, everything normally comes from the center of the mold because that's kind of like the heart. Where if you're like a tool and die maker, many times things are coming from a corner. If you are going to pick up the center, you will use something like this here, what is a dial indicator. And it works a little bit different. What you pretty much will do, there's like a little dial on it that can spin around as when you're pressing on this edge here. So you put this in the spindle and you kind of like sweep it around. So you read 0 on the dial, and then you go over and you do it on the other side. So you read 0 on the dial, divide that in 2, and that will place you in the center of the part. That's kind of like, if you don't have a fancy probe, that's kind of like how you would do that. It's up to your preference what you prefer. But I hope that this kind of hopefully makes somewhat sense. So you pick up the stock. So you got to have the right stock defined in here. Now, the next thing you want to do is when you are doing this 0, 0, you're telling the machine that this is my 0, 0, or the center, or whatever floats your boat. Let's leave it back here in the back corner. That's a pretty good way to start out here. When you've selected that, you will normally define that 0, 0. And you got options inside of your control because CNC machines are awesome. You can normally apply multiple work offsets. So before you saw here in this model here that I actually had multiple parts. So you could do that in real life. You could place all these different vices on one table, could be 3 different parts, and you could assign a 0 for this one, and for this one, and the machine will keep straight which one is where. And we do that with a G code normally. Now, this is important that I say this. Make sure you read your machine's control, because some machines, there's no standard here. I'm talking about most machines, but not all machines. Normally it's called G54. That's the first one. And there's G55, G56, G57, 8, 9. Then that number normally stops. That doesn't mean that you don't have more work offsets, because you actually normally do on most CNC machines out there. But G54 is normally what most people relate to when you say that, oh, G54, yep, that's my work offset on the control. That's where I'm telling the machine that that's going to be a 0, 0 point. Now, when I used to work at Ritlam, we actually, a couple of guys, we switched machines, or we shared machines. We would actually just use, each person had a different work offset. So I always used G54, and Paul always used G55, and that way we never messed up kind of like each other's work offsets. But you should look into your manual, because you may not know this. If you have like a Fanuc control, you can actually do G54.1 P1, what suddenly gives you another work offset. You can do G54.1 P2, P3, P4, and that will give you a whole new set of work offsets. So be aware of that. If you have a Haas, they don't call it G54 P1. They call it G54 154, I think. 154 P1, P2, P3. Look in the manual. You need to know that there is more than one work offsets. To set that inside of Fusion, let's go back into CAM. You go to the last tab over here that is called Post Process. Now, you set it right in this area here. Work coordinate offset is where you can put that in. Now, this is tricky. If you didn't know this, it might be a surprise to you. 0 and 1 both will post out as G54. 0 and 1 comes to the same value, G54, just because that's the standard one. So if you put in here 0, like we have right now, or 1, you will get the same result in your code, what will be G54. Let me show you here. So we're gonna, just so we can play around with it, I'm gonna go in and throw an adaptive inside of this pocket here, just so we have something to look at when we post this out. Okay. So we got this code here. Let's go up and click post, and you get all these different posts inside of Fusion when you install it. But of course, if you don't know, you have the post library out here. But actually, I've learned that it's only Windows users that has the link here. If you're a Mac user, just go out on Google, search Autodesk Post Library. You'll get to the same site. Now, just for the heck of it, instead of using a Haas, let's go up and select a Fanuc post here, and let's post this out so we can actually take a look at the code. It's going to come up on my other screen, of course. Okay, so this is what is important, right? All this other stuff you're seeing in here that is all pretty and all my pretty colors doesn't matter. This is what matters, the code. So what you will see in here is you will see that we got the G54 right there. That is telling the machine that whatever it reads in the control of G54 is where the 0, 0 point is going to go from. All the numbers you see, the x, y, and z coordinates, or the x, y coordinates you'll see in here, they will come from that corner we set up. Oh, I set it up on the center. Okay. I thought I left it over there. So now we would actually see the code's going to be different. So right now, if you look here, you will see that it's going to go x1, 1 inch, 333, and we post it out again. Boom, boom, boom. You will now, oh, and now it's switched over to metric because I was messing around with it. So now it goes, well, now it's going metric. Huh, interesting. All right, so you'll see that G54, I guess that's my point. If I go in and I change my setup, I was planning on posting everything out in metric. If we go into the post-processing tab here and we change this to, for example, 2, then we should see G55 in the post. So we're using that other work offset in there. Post that out. I'm just overriding the same post. And now you will see that we get the G55 in there. Okay? So when you are in the setup, this is where the importance is. First of all, what you're picking in here, if you're picking the stock box point, we're selecting that extra stock we had on our part. Now you do have an option in here to change this. I'm going to show you that just in a second to actually be right on the model if you didn't have any extra stock on it. Make sure you set your stock up right because that of course is going to affect that. And then on the post-processing tab in here, 0 means G54, 1 means G54, but then from that point on, 2 will be G55, what means you can go up to G59, what would be 6. So if we post this out now as 6, we should see G59. It's all in, select that, post it. Yes, override. So now it shows G59 in there. Now, if you want to use those extra offsets, it is actually coded right inside of Fusion, so you don't even have to do anything special. If your machine can take them, if I go in here and make this 7 and hit OK, regenerate the toolpath, post this out. You will see that now it posts out G54.1P1, what, like I said, for a FNOC control, most CNC machines, that will give you that extra coordinate system. So just be aware of that. If you have like a lot of parts, like on a tombstone or something like that, this here is heaven. So definitely be aware of that. Okay, let's go over. So now when we have done this, we machine this part here. One of the problems we're going to run into is that we can't machine all the way down to the bottom. We're going to hit the vice jaws, and I actually showed that in last Friday's live stream that we can set things up here. So when we do machine this, we will go and do a contour, and we maybe select, I don't know, the bottom edge here. That's fine, and then we would go in on the heights tab, and we could add some kind of height in here. We could add it either in here. We could add a an offset in here. Let it machine higher up. So 25 looks like that will clear the jaws, right? So if I go in and simulate this, let's just simulate the bottom one there. We are now machining around the part, but that would leave, because we have the stock in there, that would actually leave a little bit of a shelf. And that is what I simulated on the second vise over here. I just drew this up as a block. So I took this part, and then I just extruded a little bit of extra material on there. Oops, you can see that. Like there's a little lump right there. So this many times happens when you flip the part over, right? So you machine the first part, you flip it over to the second part. Now you're holding on to the good material here, but you got this extra material here. And how do you pick up the part now? Like you need to blend to this finish surface here. And you really, if you pick up the stock, there could be a little bit of an issue with that. I'm going to run over today on time too, folks. So if you got to do something in 5 minutes, then I have to come back and watch the rest of the recording, hopefully. So how do you do that? Well, let me go ahead and create another setup, because that's actually how we break. If we have multiple setups in here, we'll break it up into other setups. So I'm going to go and create a new setup. And the same thing as before, Fusion knows that it's an assembly. So I'm just going to go here and to nothing and select that's the part we want to machine. And we get the triad here. Now, again, you will see we get the shadow of the stock on our part here. Because by default in the stock environment, it will have that relative stock with an extra in here. Be aware of that if you do what I have done here and actually model up your second operation, there is an option in here to say from solid. And I can actually pick this as my stock. So I selected that whole body as the way my stock is. Now when it comes to picking up the stock, I'm not going to pick up on these snowballs here. I'm actually going to be picking up right on the model. So instead of using stock point, you can go to selected points. And now I can literally select on any intersection on the model. Now, when it comes to picking up this part, I would probably actually pick up right down here on this bottom corner here. Now, how the heck are you going to do that? And this is a common problem in the sport of CNC machining, is how the heck are you going to come in here and pick this up, because you have this like hat going around the outside. It's kind of like in your way. You couldn't get down here with an edge finder. There's a couple of different tricks here that I wanted to share with you. First of all, if you are using the center instead of the corner, you could possibly get down with one of these indicators where you can kind of like bend this arrow down and you could get below the stock. But what I actually used is I had a couple blocks like this ground up, so I know exactly what size they are, and I would lay that against the good side from the previous operation. So lay that up against this green face right here, so it's kind of like sticking out underneath that hat area, and then use that to either touch off with the edge finder. So just hold it against the good side and then pick that up, and then just subtracting that width of the block. Now you need to have something that is pretty reliable and pretty square with that. But that is one trick. Now another thing that somebody's going to say, all right, so that's a good way to pick up the X and Y, but what about the Z down here? That's a little hard too. I used to pick up my Z axis on the solid jaw on top. Now most people, if you have taken CNC school, have learned to pick up the top of the part. I actually never preferred really to do that. I would normally do it on the solid jaw on my part, and then just compensate for where I knew this 0 was gonna be. And now I'm running over, I might as well just run all the way over. Another quick trick when it comes to touching off your tool on CNC school, I'm just making that up, I don't know if that's a CNC school, piece of paper, and then you put the piece of paper down on top of your stock, you go down with your end mill, and you move the paper, and you just go on the dial until you can feel the paper binds, and that is normally accurate enough till you can say that is where my tool should chop my stock in there. I don't like to do that personally. Again, this is all about my personal preference. Why? Because now the tool is right here, And too many times, man, I have dialed the dial the wrong way. Tool goes right down the stock. Tool breaks. It's silly. Goes back to my previous, this block again. The way I normally touch tools off is I would put this, if you're going to do it on top of your part, I'll put this on the top of my part, come down with my tool like this. I will push this, just hold it against the tool, and I will start moving my tool up. And as soon as my block goes underneath my tool, I know that it's snug. I know that now I am at a dimension. I just got to, again, subtract the thickness of this. And I don't risk that if I move the dial the wrong way, that I hit my stock. 2 cents. That's all I got. So that is how I would normally pick up the part here. And like we did before, we can go over to the post-processing tab, and we can put in whatever work offsets we want. So if the first one was G54, this one would probably be G55, and that would be number 2. And then this would be G54. Last thing I want to talk about, one other thing I got to show while I'm in here. I got a question, I think it was last night, about facing off. If you got to face off your part in Fusion, we have the facing operation up here. And if you click on that, you hit OK, you get this facing operation that will just kind of like going back and forth, just facing off. Now, this question I got last night was, why can't I do an adaptive facing? Now, remember adaptive. We talked about that a few Fridays ago, how awesome that is. So if you missed that, you got to check that live stream out. We talked about that adaptive keeps a constant load on your cutter, where this standard facing operation, that's a good old-fashioned, don't do that. They can leave slivers and things like that. The way you do a adaptive facing is very simple. Go into your adaptive tool path, select your tool. When it comes to your geometry selection, don't select an edge like I normally always tell you should do. Select the face. Then just make sure you go into your passes tab, because stock to leave will by default be on. Turn that off and hit OK, and you will now get that perfect constant step over on your tool path. Okay, I hope that was not too quick. Okay, last thing I wanted to talk about. I hope this is useful. You let me know in the comment area if it is or if it isn't. Let's talk about probing, because then some smart guy decided that we could put spindle probes in our machines to pick up our parts. And Fusion have this in it. So let's create another setup here for this part. So I'm going to create a new setup, the third setup. Again, nothing, and then click on the part. Now for this one here, I'm also just going to pretend that there's no stock on this model. And so, well, you know what? That doesn't really matter. Let's just leave it at stock. We have a little bit of extra stock on the part here. And we're going to say we're going to pick up, let's pick up that center point right there. So in this case here, our stock would probably be what? 56. So that would be number 3 you want in here, right? Now, Fusion has this cool probing technology that a lot of machines comes with a probe where you can touch off your part, and that's the way that you find your G54, your work offset, your zero, whatever you want to call it. So we're going to select probing. First thing in here is going to give you a tool. So it's just like if you're machining. And I already have a probe in here, but the way you find it is right in here. There is actually sample probes in here that you can select from, depending on. You see, there's all different kinds of styles in here. Come into geometry. You just got to select what you want to where you want the probe to touch. So I'm going to select here, and when I select that face, you will see the probe is touching right on that face. And I also want to select this face, and now you will see that it select those 2 areas. This probing is pretty intelligent in the matter that if I go down here, and let me X out of this, if I go down and I select this hole, it knows that it's got to hit a hole. And it's actually smart enough to know like things like that. I'm not sure what happens. If I select the face here, you will see that it's just going to do a Z surface in here. But you can select the inside of these, and it will actually know to touch off all the four walls. So this is pretty intelligent in here. I'm going to select these two faces. And then you will actually see it's asking me up here if I have stock specified or not. So I did have stock specified. So I should select the stock and not the part itself. So you can do that here. And I'm going to just hit OK to that. Now, here's where I think, not that there have been any confusion, but you saw before inside of my setup that I have in here something called probe work coordinate override. And this is important if you're going to play around with the probing, that you know about this, because think about it like before. We talked about the machine needs to know where your part is. It also knows where the probe is. So the probe will normally has its own work coordinate system that it is using. So that will be tied into, like when I used to work at Ridlam, I had all my probes tied into G59. I just don't use G59. That's where the probe lives. Now, some people decide to have the probe on G54, where the other one is. That's really your preference. But if you have it at G59, that will make number 6 in the value. If I change this to 6, I am telling the software that I want you to use the probe that is assigned. The probe itself is designed to work offset G59. What I want the probe to set is number 3, what in our case is G56. Remember that, like I said before, 0 and 1 is G54, 2 is G55, 3 will then be G56. So if I go in here and hit OK now, and I should probably also, we should have a toolpath in here for this, just because it's more fun when there's actually code on it in our thing here. Okay. Now if we go and post this out, and then I'll wrap it up now. Then you will see we get this probing section right here. And in that probing session, that goes in here, and now this is a Haas probe on a FNUC control, whatever. But you will see here that it calls up G59 for the probe. So it's important that you're ever going to look to the code. You know this. That was that number 6 in there. And then if you go down and look down for my actual tool path, that's why I wanted a tool path in there, then it's switching to that G56. I really hope that this was worth 38 minutes of your life to watch this. You need to let me know. Thumbs up if you like it. Thumbs down if you don't. Be honest. But, it's depending on where you are in the whole CAM environment. These live streams are really I really just want to add maybe a little bit more value to you using the software. And we have people on different levels. But I hope that you pick something up in here that can be useful for you when you go out in front of your machine. All right, guys. I can see that L joined in here. It's absolutely awesome. Really appreciate it, L. I'm going to do what I normally do. It's Friday. I'm almost ready for a beer. I am going to end the broadcast. So if you're watching the recording, thank you so much. Really appreciate it. Don't forget. And I will be checking out one other thing. Down in the description area of the video, don't forget, there is the free CNC Handbook. All you do is put in your email address. I get the email address. I am not going to spam you. Promise you. You can get the free CNC Handbook. It's awesome. It has a lot of information like this in it with work offsets and things like that. So definitely check that out. Thank you so much. Hope you have an awesome weekend. End the broadcast, and I will jump into the live stream and say hi to everybody. Take care, guys.